All right, we're looking at whether these are true or false. So one nice thing to think of is whether you have an even or odd function. So for example, here's an odd function between minus a and a. So this area will be negative, but exactly the same as this one. So the integral actually equals 0. So that's the case for a. It's between minus 90 and 90, and it's an odd function. So it's going to end up being 0. All right, if we look at b, have a look, is that an odd function? Well, just put negative x inside there and you get sine negative 4x, cos negative 2x. So sine is an odd function, so another way to write it would be that. Cos is an even function, so another way to write that would be that. So you can see that's going to end up being negative f(x). So again, that is an odd function. So if I go between minus 30 and 30 and integrate, I'm getting a negative area, positive area that equate to each other. So I'm going to end up with 0. So that looks good as well. Whoops, what happened? All right, so let's go to here. C. This function here, we know 2 to a power is always, so another way to write that would be 1 on 2 to the x squared. We know that's always greater or equal to 0, sorry, not equal, greater than 0, it's always positive. So, you know, if I'm going between negative 1 and 1, it's always positive, so I'm definitely going to get a positive area. So this one would be false. All right, that's false. Okay, so for, what are we up to, D? D, now that's an interesting one because D and E kind of, if I look at this, all right, so if I have, let's see how I go with this. Oh, that's really bad, but maybe if I do the green one again rather than, sorry about that. Okay, so let's go again. That's probably better if I do it that way. Damn, that should go through there. All right, so if the green one is y equals 2 to the power of x, then the blue one would be 3 to the power of x. So for example, if I go to 1, did I just do that wrong? To the power of 1, so it's going to be the opposite, isn't it? So this is going to be 3 to the power of x, this is going to be 2 to the power of x, because that'll be equal to 2 if I put 1 in, 3. That'll be equal to 3. So that's it there. All right, so that looks better. So you can see that 2 of x between these limits 0 to 1, 2 to the power of x is less than 3 to the power of x, so the area under the curve will be less. So this one looks good. But this one is between 0 and negative 1, so in this section, and you can see the area that will be bigger is the blue curve, so 2 to the x will be bigger. So this one will be false for that area. All right, and what about F? Again, be careful with your limits here because we're only going between 0 and 1. So if we weren't looking at that, you'd go, oh, look, I'm dividing something that's bigger over here, so then this side will be smaller. But between 0 and 1, think about something like a half. So on that bottom there, a half, you could write 2 to the negative 1. So say t was, so the bottom would be, excuse me, 2 to the minus n, for example, for a half on that side, and on this side 1 plus 2 to the minus n plus 1 on this side. So it actually does the opposite between 0 and 1 to what we originally would think. So yeah, so just be careful, a little bit careful there. So whereas here I could think, oh, I'm dividing by more, hence this will be smaller. Actually, this is bigger in this case because we're only going between 0 and 1. So therefore, F, yep, it's bigger. So that is correct.